Hello everyone, and in this video we're gonna finish it off the DASM assembler with the macro, so stick around for that. Okay, so let's finish it off, this DASM video series, and let's go over the last directives or pseudo-ops. First you have set, which is equivalent to the EQU, but the only difference is can be reassigned later. So remember, so EQU is something like this, or I could just give it like that. So that's the only difference. So that's set. Then you have a mac and macro. So all the code within this is our body of our macro. And you have exit, conjunction conditions. You can exit the current macro level. So that's the last four. So let's just look at examples that come with their macro header files. So let's go over the good one, like clean start, and let's paste it in your code and see it works. So all you do, mac, give it a name, and mac. So all of this is our body of our mac. So whenever I call clean start on our code over here, it just should paste all of this code should go to our let me close this, to our Atari over here. So if I come over here and let me go over here, my macro, bring it over here, and here you have it. You have SEE, CLD, load X, transfer X to A, so forth, branch, and so forth, and push A. So as you see over here, instead of untyping all of this, I can just come over here, include my macro header that comes with our DASM, and just put clean start. So that's one thing you can do for macro. So let me close this. And now let's just look at another one. Like here you have vertical sync, have sleep over there. Let me go to pointer. Here is the author of pointer, manual Rorschach, and sets 2 bytes of RAM to pointer to absolute address. And if you notice over here, you have mac set pointer. Then you give a temporary label to hold a temporary value, and set, and then it's open brackets over here, and then 1. So this is gonna actually let me show you. Go sleep, same thing. Sleep, have a dot sign, and then 1. So let's put sleep over here. Sleep, and then give it a value 1. I'm gonna sample, give us an error over here. If you go all the way down, which I expected should happen, let me clear and assemble this one more time, since it's faster. So mac error, sleep duration must be bigger than 1. So if I go over here, macro, so if dot cycles, which is their value of 1, is less than 2, give it an error, like hey, it has to be bigger than 1, and exit with error. Otherwise, just come over here, and if it's not in legal opcode is not on, not in a 0, else bitsync vsync, and so forth. So if I were to sleep 4, come over here, 2 nops, nop. Let's give it an uneven number, nop, and then a vsync. So that's the sleep. And if you come over here, the pointer was showing, I can put set, we can have multiple parameters for our mac. So set pointer 1 and 2 or so. Pointer 1, 2. Is it pointer? Set pointer. Let me copy and paste. 1 dash and 2, and so forth. So that's the macro. So before we go, let's just make one for ourselves over here. So let's start with Mac, like content system, because you already gave me an Mac over here. So nmac, and let's give it a name, even or odd, and then I don't know. Let's if give me an if over here, and then else. So let's put give it a def val. I'm gonna set 1. So then let's do this. If dot val local, and then we have our modulus 2 is equal 0. Equals 0. Echo, if I can step. Echo even. Else odd. So this is our macro. And if you come all the way down over here, we can have documentations. You have our binary, what's that called? Operators. And here all the operators I can use. So I'm using the modulus. Here it is, mod, and all of this you can use. So that's our macro over here, and let's use it. Let me just copy and paste. Set 3. Assemble. Oh, should be on console. Let me clear here. Assemble one more time. Go all the way to the bottom. Odd as expected. 4. Let's go to console. Should give me even. And that's gonna be it for this DASM video. And in the next video, I'm gonna go over how a CTR screen works, because we need to have that knowledge in order to work with the Atari 2600, since you're responsible to displaying those pixels at the screen, unlike other consoles. So that's gonna be it for this DASM assembler. Thanks for watching all this video up to now, and see you guys in the next one. Thanks.